Good morning, students. I'm Professor Anil Gogte. Today I'll be giving a brief introduction about the syllabus Biomedical Image Understanding and Analysis. This is professional elective which will be floated for 5th semester students of electrical and computer science and IS streams. So I'll give you overview the importance of this subject, as well as you'll have some idea which are the openings in healthcare sector. We know today, if you look at this year or last year or the future decade, we say that it will be more towards the healthcare. And we have seen during the pandemic situation what happened, the work pressure on clinical side towards the doctors and hospitals, screening of any data sets like CT scan, MRIs, then pathological data. Is there any provision the technology could be employed for betterment of healthcare? So, biomedical image processing, it is allied, or I can say it is a part of biomedical engineering, which involve more dealing with images and making some assessment. And at the end, these algorithms are kind of a programs or assistance to the doctors, moreover. And at the end, a doctor will have, or a doctor or a clinician will have a tool which can assist him to increase his screening speed. Okay, so I'll give you the overview of this syllabus. So, when we look at the curriculum or the syllabus of this subject, it is considered you will not have any background of image processing. So, first chapter will give you overview of entire image processing, the minimum entity. Minimum entity in the sense, the formation of image and formation of image, like construction of how image is constructed. And we know today whatever we deal image, when we say it is basically a matrix with rows and column combination. And we know this is a sort of information. And any computer will store information of image in a form of pixels, which is again at the bottom level, it is a binary information, I can say. So you will be dealing a digital information or a data at some level. In this, we start with formation of image, then we take modalities of image. But here, I will introduce you different 5 modalities, but moreover, the remaining chapter will focus only with CT image and MRI image. We will not be getting into more into like ultrasound images or etc. other modalities. Due to the limitation of time, we will be focusing only on 2 modalities. But you'll have overview of all 5 modalities which are available in medical domain. Our focus would be with CT image, MRI image, as well as some histological images we will take up as example to deal this subject. So, when I say image, it is a matrix in bits format. So it is represented as rows and columns. Here we deal with image algebra. Several examples we will deal. Then we migrate to transforms. So here, like what are the transforms we deal? We understand the fundamental concept of the transforms. Then we apply these transforms to our modalities. For example, enhancement of resolution, maybe feature extraction or histogram equalization or etc. So we will take these transforms. Also compression also is one application we can take. So here also we deal with enhancement process in frequency as well as spatial domain. Resolution is one of the most important. Whatever we are dealing today, it is more or 3D information, but soon in another few years, we will be getting these MRI and CT images in a form of 4-dimensional. So you can imagine the resolution will also change, and whatever the machines we use, they are of might be around 7 Tesla resolution. So we deal the resolution is one of the most important parameter in biomedical imagery. Then we conclude this first chapter with the image. Also, we have another topic like restoration. Like any degraded image, we can reconstruct. It is a reverse process or inverse process, I can say. Then medical applications of imaging. Then frontier of image processing in medicine. This will give you overview why we need to study this subject from healthcare point of view, and what are the future scope or future market to get in. So every chapter I will be dealing with MATLAB image processing toolbox. Okay, so first chapter will introduce you about the basic fundamentals of biomedical image. Then comes understanding and analysis. So when we talk about understanding and analysis, it means that your computer or your program should have an intelligence. It should have inbuilt intelligence. And this intelligence we can build using some softwares. And without these softwares, we cannot build intelligence in the algorithm. So for the building this intelligence in an algorithm, we use a tool called deep learning. So the remaining 4 chapters focus more towards the applications of deep learning in biomedical image analysis and understanding. So the next chapter, second chapter will give you evolution of deep learning technique from neural network. So as I said, each chapter you will be exploring a MathWork toolbox. In this entire syllabus, we will be dealing with total 3 toolbox, that is image processing toolbox, then we have deep learning toolbox, then we have machine learning toolbox. Okay, so from my side, I'll be demonstrating these all example with real-time data set using MathWork. And I expect at the other side, the student should implement the same algorithm using a tool, Julia. Okay, so that's a next era which we find more openings in the market. So I expect the student to implement the same algorithm, whatever I'm implementing in MATLAB should be replicated into other programming language, that is using Julia. So let's go to the second unit. Second unit is completely evolution of deep learning, how the intelligence is built, and what are the segments involved in an entire intelligence. We are listening today in most of the technology, either machine learning or intelligence. So here, basically you are dealing with the data, and the generated data, what we say image is large data. So I can say here, whatever the modalities we use and the data generated, it is basically a big data. And to deal with this big data, we need a tool which can handle such enormous data. And deep learning is a tool which can exploit to the maximum extent. So in the evolution, we start with machine learning. We give overview of neural network and what are the limitations. That's why they migrated to deep learning is explained. So here you will be dealing, you will be doing a kind of a review. So what does review? So you will be referring a good number of literature from standard reference papers, maybe from good transaction papers or elsewhere. We will be taking some set of good papers, and related to that, you will be doing a review. Then different types of deep learning architectures you are going to study. For an example, we have more number of deep neural network tools are available, but our focus would be restricted only with CNN, that is convolution neural network, and recurrent neural network. And in that again, we will be focusing only with one network, CNNs, that is convolution neural network, which is basically a convolution operation of mathematics. So whatever the applications we have today, more number of application in biomedical image processing, like wherever we have the intelligence, they are done more with, if you take current trend, I'm talking the current trend, maybe since from 2017 to 2021, if you take, a huge amount of research happened using CNN. And whatever the next will be, with kind of a hybrid deep neural network, will be a combination of CNNs and RNNs. So we will be studying a little bit about RNN, that is recurrent neural network. And I can say here the recurrent neural network is little enhancement with convolution neural network. Okay, so the same all deep learning examples, we start with, we use MathWork Toolbox. We have a MathWork deep learning toolbox. So I'll be explaining neural network, deep learning, machine learning, CNNs with reference to MATLAB. And I expect the student at the other side, they replicate same with Julia programming for deep learning. Okay, the third chapter is, that's what I said, second chapter, we give overview of which deep neural network you are going to use. In that, as I said, we will focus only with convolution neural network. Like you have several, but our scope, again, we are limiting here only with CNNs. So the third chapter will focus entirely on CNNs. We start from scratch and we end up with pre-trained models. We have several, again, CNN models are there that will be taken in unit number 5 with examples. So we will be dealing in detail of 4 different pre-trained DNN models which we use. This is about overview of third unit. Then fourth unit. Fourth unit is segmentation. So for any analysis or understanding, for an example, whether the tumor exists or not exists, you need to separate from the image and do the analysis. So if you take the latest MRI machines, they will scan and they can generate a segmented image. The machine is generating such images. So we need to understand how the segmentation is carried out. Here also, I will give you the fundamentals of segmentation, image segmentation, and that will be elaborated with reference to deep neural network models. So we will be dealing with 3 different segmentations which are core with deep learning. This first one is SegNet, then we have UNet and VNet. We will understand these segmentation techniques. Also, we will introduce little bit about which are the benchmarks worldwide it is available, which we can explore along with our subject, and which are the available challenges are there which we can participate. There is something called Grand Challenge. So I want those who are interested with this subject can just go through these, just go Google with BRATS, you'll get a link. Similarly with Grand Challenge. Every organ will have one kind of a challenge worldwide. And that along with this subject you can participate, you can consider yourself for a long duration, say 1 year or 2 years, and those events will be open for 1 year or 2 years based on that. But this will give you an opportunity to participate in such challenges. So this is about my fourth chapter. Then I have a final chapter. Final chapter, the title is Deep Learning, Medical Image Classification, Analysis and Visualization. We know that for any classification, we need features. Okay, so features are one of the most important parameters which we consider. We'll let you know what you mean by features and which are the features, how these features are extracted, and what is dimensionality and why this dimensionality reduction is very important. And here I will tell why CNN is most important when I compare with other deep neural networks. Why I have chosen only with CNN and restricted myself. Because the time is also another factor I need to consider. So I have taken only with CNNs. Okay, so we use these CNNs for feature extraction as well as for feature extraction, then object classification, or I can say the image classification. Say for an example, identifying and classifying whether it is infected or not infected, a simple two example that you can consider, and further still you can elaborate. Let me give you one example. Like recently we have seen COVID, it still exists, and we normally take a CT image, and that's our fastest way of kind of assessment whether it is infected or not, that you can do using, there's a parameter called GGO, ground glass opacity, so that you can use to assess whether it is infected or not. Certainly, it is not the final assessment. Along with CT scan, they consider RT-PCR test and etc. they have. Then they come up with a conclusion, the patient is infected with COVID or not COVID. Then, if it is infected, again they say, like, they call as Coride score or CT score based on the infection. That classification, like infected moderately, infected very heavily, or not infection, that kind of a categorization also you can do using the segmentation algorithms. Like there is semantic segmentation which you can use in such applications. Similarly, the grading of cancers will be there. Like most of these cancers, we take a biopsy, then we have histological images, then we grade them with M1 to M5. Grading will be there, and that will tell you the concentration of grading. So that kind of grading also you can do. So here, as I said, my CNN applications would be focused towards feature extraction and classification. In this chapter, I have taken around 4 different CNN models. So we will be dealing with VGG19, then we have AlexNet, DenseNet 201, then ResNet 50. These are the 4 pre-trained models. We take one example of pulmonary disease and CT image for comparison wise, and we will understand in depth how these works. So all these implementation, whatever I'm going to demonstrate, are implemented using MathWork, MATLAB. And we have, as the campus-wide license, you all are, you can make best use of this tool, which I feel. And apart from that, the same example you can code in Julia also. So this is the overview of the subject. Let me tell you the team members. This is my team whom I'm associated. So myself, Anil B. Gogte, I'm from EC department. Then we have from MathWork, Dr. Praful Pai, who is my associate in most of these projects. Also, we have another guy, Amit Kamath. So from technical team, we have 3 members, and they will be interacting with you regularly in the subject. Also, from clinical side, we have 2 people from medical domain, Dr. Rajendran Nirli, who is a well-known urologist from JNMC Hospital and practitioner from Kelia Hospital. Also, we have Sridhar Gagne, who is associated with whatever the projects I have told to you. So you will get an exposure of programming side as well as from clinical side. So this is what I have overview of the subject, and we are limiting the students also. We are initially making a small group, and those who are interested, we will be putting them into the projects which are ongoing with our team. We have 2 projects which the duration is around 1.5 year to 2 years. We have 2 big projects going on. So we want a dedicated student who can be part of this. But I'm very sure if you take this subject and compare today's trend into the biomedical trend, definitely you'll appreciate. Hope to see you. You'll opt this subject, and we can find the best win-win situation for student as well as from researcher point of view. You'll understand how to do little research into the biomedical imagery part. Also, we are associated with some of the industries like Medtronic as well as Philips in several aspects. You'll be dealing with those also. You'll be interacting with people from industry other than my team. Okay. So, if you have any queries or any clarification you want, you can contact me. This is my mail ID. You can write to me, and if you want any clarification, what will be the openings, and if you do this subject, what benefits you have. If you're, I think I can say the next 20 year will be with more with healthcare sector, and we will have several openings which require these kind of algorithms. And when you are able to, another one good part of this subject is maybe biomedical is one application. The same application you can elaborate for any other application like video analytics. You can implement on satellite images. Then many other applications also you can correlate with these algorithms. So okay, so if you have any difficulties in with these, or you want more clarification about the subject, you can write to me. You are always welcome, and I would be very happy to deliver this subject and whatever the acquired knowledge I want to share with you. Okay, so let me stop here. Thank you for patient hearing.